everyone. Today we are going to talk about integration by substitution, also called the reverse chain rule. In order to better understand the reverse chain rule, we first need to revisit the chain rule. Recall that if the chain rule states that if we have a function, composite function f of g of x, and we take the derivative of it, we can rewrite it as the derivative of the outer function with respect to the inner function times the derivative of the inner function. Since integration is the same thing as antiderivative, what we need to do is we need to take the right-hand side, which is the derivative of my composite function, and find out what the original function is. In order to do so, let me integrate both sides of this equation. Since we know that the integral of the derivative is just the function itself, we can rewrite the left-hand side as f of g of x. And this is going to be equal to the integral of f dash of g of x times g dash of x. Now, how are we supposed to integrate the right-hand side of this equation? In order to do so, let me take g of x and let u equal to it. Now, let me differentiate both sides of this equation to get that du by dx is equal to g dash of x. Now, since du and dx both represent small changes in u and x, we can treat this like a fraction and multiply by dx on both the sides of the equation to get that du is equal to g dash of x times dx. Note that this is same as this part of my integral. So I can substitute this du for this over here, and I can substitute u for g of x. Doing so, we get that f of g of x is equal to the integral of f dash of u du. To recap, in order to find the integral of the derivative of a composite function, all we need to do is recognize the inner function, which in this case is g of x, and then let that equal to u, and then we substitute that into the outer function, and then we integrate the outer function to get the answer. Let us take an example to better understand this. Let us try to find the integral of 2x sine of x squared dx. Now, looking at this function, we can see that the inner function here is x squared. So let us let u is equal to x squared. Now, we can differentiate this on both the sides to get du by dx is equal to 2x. Multiplying by dx on both the sides, we get du is equal to 2x dx. We can substitute that in the original integral to get that it equals the integral of sine of u times du. We know that the integral of the sine function is equal to minus cos. So this can be written as minus cos of u plus c. Now, since u is equal to x squared, we can write the final answer as minus cos of x squared plus c. Now let us verify this. We can differentiate this function by using the chain rule. Here, cos of x is my outer function and x squared is my inner function. Differentiating this, we get that the derivative is equal to minus of minus sine x squared times 2x plus 0. And this can be rewritten as sine of x squared 2x, which is my original function.